Welcome back everyone. This is the session 12 from the playlist of friction. The topic is the calculation for the acceleration of a hanging block which is connected to a block resting on a rough inclined surface. So with reference to this topic, I have already drawn here one figure, and in this figure this block of mass m2 is hanging, and it is connected to this block of mass m1 by an inextensible string. So this is a string, this is an inextensible string which is passing through a frictionless pulley. Now in this case I have taken the frictionless pulley, and the coefficient of the friction, or you can say that the coefficient of the kinetic friction between this block of mass m1 and this inclined plane is mu, but here the pulley is taken as frictionless. So here in this case, this block m1, this block of mass m1 and this block of mass m2, they are connected by a common string or a single string, and this string is inextensible. And since this block of mass m2 is moving downward, so this block m1 will be moving in the upward direction. And since this is the inclined plane is rough, and the coefficient of kinetic friction between this block and this inclined plane is mu, therefore the force of friction will act on this block, and it will oppose the relative motion. Relative motion means that if the block is moving in this direction, the force of friction will be acting in the backward direction, or you can say it will be acting down the plane in this case, that is in this direction, and here I am indicating the force of friction as Ff. So this force of friction will be acting down the plane because this block is moving up the plane, and the force of friction opposes the relative motion. So now here these two blocks are connected by a common string. Now we know that the tension always acts away from the body, so the tension for this block will be acting in the direction as indicated by this arrow, and the tension for this block m2 of this block of mass m2 will be acting in the direction as indicated by this arrow. Now here what I have done is I have already resolved this weight component of this block of mass m1 into one component which is perpendicular to the plane of this inclined which is perpendicular to the inclined plane, and there is one more component which is parallel to the inclined plane. So this component which is perpendicular to the inclined plane is equal to m1g cos theta, because this angle is theta, so this angle will be theta, so this component will be m1g cos theta, and the horizontal component will be equal to m1g sin theta, and this horizontal component will be acting down the plane as indicated by this arrow. And now the coefficient of friction is given here as mu. So the normal reaction, this force of friction which is taken as Ff, so this will be equal to mu n. Now the normal reaction here will be equal to m1g cos theta. Here the normal reaction will be acting perpendicular to this inclined plane, which here I have already indicated this here by n. This is the direction of the normal reaction, and the force of friction is equal to mu n ho gaya. Now mu n is equal to m1 g cos theta. So this is the value of the force of friction. This force of friction will be acting down the plane because this block is moving up the plane, and the force of friction opposes the relative motion. See the total force which is acting in the down the plane. Total force acting down the plane, down the inclined plane. this is equal to m1g sin theta plus the force of friction, that is Ff, which is equal to mu m1 g cos theta. So this is the total force which is acting down the inclined plane, and the force which is acting and this is the force which is acting on this block of mass m1. Total force acting down the plane on m1. Okay? Now the force which is acting on this block of mass m1 in the in the upward direction, or you can say up the plane, is T. So the net force on m1, this will be equal to T minus m1 g sin theta plus mu m1 g cos theta. So this is the net force which will be acting on this block of mass m1, and this net force will generate the acceleration a. So this can be written as, which will be equal to m1a. So this is the first equation which I have got. Now consider this block m2. The weight is acting in the downward direction, m2g. Now this block will move in the downward direction only when the weight is more than the tension in the string. So weight is equal to m2g minus the tension in the string, and this will be equal to m2a. So this is the second equation which I have got. Okay. So from here, what I will, and this was the first equation. So from equation 1 and 2, from equations 1 and 2, what I will do is I will be adding the equation 1 and 2. So if I add 1 and 2, this t and t will get cancelled out, and finally I will be getting the value as m2g minus m1g sin theta plus mu m1g cos theta, because I have added, so this minus t and this t will get cancelled out. However, m2g, I will get m2g minus this this value, and this is equal to m2a plus m1a. So this is equal to m2 plus m1 in bracket a. So this is the third equation which I am getting. So from the equation number 3, I can find the value of acceleration a as, see here, I am getting m2g minus m1g sin theta minus mu m1g cos theta divided by m1 plus m2. This is the common acceleration of the blocks having a mass m1 and m2, and if you want to simplify this equation, we will get the value of this common acceleration as, here m2g, we can simply write this m2g, and here this m1g is minus m1g is common, so you can write it down here, sin theta plus mu cos theta. The common acceleration can be written as m2g minus m1g is common, so I will write here as sin theta plus plus mu cos theta divided by m1 plus m2. So the common acceleration of these two blocks is equal to this value, that is m2g minus m1g in bracket sin theta plus mu cos theta divided by m1 plus m2. So here the most important thing is that in order to calculate the value of this common acceleration, you have to first of all see that if the block, the direction of the motion of the block, now since the force of friction opposes the relative motion, so accordingly you have to take the direction of the force of friction, and then you have to use a concept that a block moves in a certain direction only when the net force in that direction has got a certain value. That is, this block will move in this upward direction only when there is a net force acting in this direction. So based on this concept, you can find the value of this common acceleration, and after finding the value of this common acceleration, you can also find the value of this tension T. Now tension T, how you can take, we got one equation, that is m2g minus T was equal to m2a. So after finding the value of this acceleration A, we can find the value of T also. So thank you very much for joining this session. In the next session, I will be coming up with a different type of question. However, the topic will remain the same. So till then, have a nice day. Bye.